Every year, we follow a programming process to program our controller according to what we need to accomplish with our robot. We start by programming our controller to use tank drive mode, which means we use a joystick for each wheel. This is because our drivers find this the easiest way to maneuver the robot. We always assign port 2 and port 9 of the Cortex to the wheels. Secondly, we experiment with the new joysticks we receive from the returnables kit and decide how much of a deadband we need to add. A deadband is a code block that makes any joystick value from -10 to 10 equal 0, so that if the joystick is off of absolute 0 just a little bit, we won't move. Once we have our robot built, we decide how to use our small motors by determining which of our robot's features is the primary arm and which is a secondary arm, or wrist. These small motors are assigned ports 3 and 8 on the Cortex. We assign the primary arm to the 6 up and down buttons on the right side of the controller. We assign the 5 up and down buttons to whatever the secondary arm is. Next, we look at how many servos we're using and what range of motion they require. We use this data to base our limits for the switch block. A switch block switches a preset value to a different value. Servos are always assigned ports 4 through 7 on our robots. Finally, we examine the extra thing we have to do each year, either an autonomous function or in this year's case, changing the IR sensor, and we program whichever buttons we have left to do this. We use the UART on our robot to output the commands from the controller to the IR sensor. The Simulink control system for Royal Technic's robot this year includes a 4-wheel drive, 2 arms that are part of a 2-bar linkage, and a rack and pinion that moves to operate the levers on the field control box. Our designers developed an independent double gear reduction 4-wheel drive system to power our wheels, adding maneuverability and speed. This uses both of our large motors. Our lever operating arm moves left and right using a rack and pinion and 1 small motor. Our arm moves up and down using a gear system and is powered by the other small motor. Finally, our IR sensor uses the UART on the Cortex. The first part of our code is the drive system, which is shown above. When the joysticks are moved, they output a signal with a value from -127 to 127, depending on how far and in which direction the joysticks are pushed. Our primary arm uses a code that sends a signal of 1 if 5 up is pressed and a signal of -1 if 5 down is pressed. These signals are multiplied by 127 to use our motor's full power. The rack and pinion uses the same code. We did not find it necessary to use any servos this year. In our field control box commands, we use buttons to send a signal of 1 that gets multiplied by the correct hexadecimal code from page 37 of the 2022 Best Robotics Competition rules. This signal is then sent to the subsystem given by Best. Thank you for listening. This has been the CVCA Royal Technic Simulink video.